Looking at number 13. Number 13 states H is a centroid of triangle BDF. We're given the length of DF is 50, CF is 42, and BH is 22. We'll try to go our best in this order, but if it doesn't, then it's fine. So first, what we're going to do is we're going to look at the length of DF. So DF is actually on the outside, and we're given a centroid. So let's just start labeling everything so we can make everything much easier. BG is congruent to GF. EF is congruent to DE. DC, 2, 3, is congruent to SB, 1, 2, 3. Okay? So we have DF is equal to 50. So I'm going to represent that by showing a full length. That this is going to be 50. So that full length is 50. We know we have a median since we do have a centroid. As a result, if this is 50, EF has to be 25 and DE has to be 25. So what we have, EF is 25 and where's the other one, DE? And DE is 25. Next, what we have here is CF is 42. CF is representing an entire length. And it'll get a little messy, so I'm just going to highlight this with orange. CF is congruent to 42. Then we have BH, which is only a half a segment, is represented by 22. So I can write that one in. 22. So the way we're going to do this is just start with HE. But we're looking for HE. HE represents a third. So the way I'm going to solve this one is we're going to take a look at our BH. We've given that BH is 22. We want to know the entire length. And then we can use like line segment addition postulate or work with it easier than that. So first, we want to set it up that BH is equal to 2/3 of BE. Well, in this problem, we're given BH, not BE. So what we need to do is just flip the problem around. Multiply 3 halves to both sides. Multiply by 3 halves to both sides. Cancels, cancels. So we get 3 halves times BH will give us the entire length, which will give us a lot more information than we need. We know BH is 22, so 3 halves times 22 will give us BE. So you can just use your calculator to figure this one out real quick. You have 3 times 22, and then you divide it by 2. You get 33. So the length of this is going to be 33. So the length, the entire thing is 33. And to help us see that, I'm going to highlight it with a yellow. And we actually do have BE in the question, so we can fill that in. It's all the way at the bottom. But we're still looking for HE. HE is a third of it. We know a third of 33 is going to be 22 or 11. But we can check it out. We have the following for it. Just write a little line up here. HE, the length of HE, is equal to 1/3 of BE. HE, we don't know it yet, is equal to 1/3 of BE, which is 33. And a third of 33 would be HE, is equal to 11. Next up, we're looking for HF. HF is from a vertice to the middle. We know that we have the entire length, which is going to be 42. So what we're going to do is we're going to figure out what the third is, and then we can use the line segment addition postulate to figure out the other part. So we know from the vertice to the centroid is 2/3. So the way we're going to solve this is we're going to do FH is equal to 2/3 of the entire length of 42. So the way we're going to solve that, you can do 42 times 2 divided by 3 will get you 28. So the length of FH or HF is 28. And to figure out the last part, I'm just going to use the line second addition postulate for this just to show you another way to do it. So the way we're going to do that is we're going to say that we have FH plus CH is equal to FC. We're given FH, which is 28. We don't know CH yet, equals, what's the entire length? Equals 42. Then we can just subtract right here, and we get 42 minus 38 will give you a length. 2 minus 28. You'll get CH is equal to 14. And that's how we can use the properties of a centroid to find the missing answers.